Hello, test. There we go. Hey everybody, it's a little early. Well, it's not early actually, it's 8:30, but I'm just going to get started anyway as people drag in because it's, early in the morning. I just wanted to say how much I appreciate everybody dragging their ass out of bed at 8:30, well actually earlier than 8:30 to be here. That, right here, it just touches me right here that you would do that for me. The last day of the conference, that's really cool. After eating steaks the size of a tennis racket, which we did last night apparently. That's really cool. By the way, so I was in my hotel room this morning making coffee out of that little crappy coffee machine they give you. And the coffee is called Cafe Valet Gourmet. And so I thought, the best coffee is that which rhymes. Like that. That's how you know it's awesome coffee. And I discovered that everything on this coffee packet was a lie. Everything. Like, it's not a cafe. I'm in this weird hotel room, magical hotel room at Disney, right? And then it's valet, it's not valet. Like, a valet means someone does something for me. Like, I don't do it if it's valet, right? Like, someone parks my car for me, brings back later. That's valet. This is a coffee that I have to make myself. It is not valet in any form. And then it says gourmet, which is also impossible. You don't get gourmet coffee in a packet, which then has another smaller packet inside that you cram into a little coffee pot with a broken thermostat that gets water all over the counter. Like, that's not gourmet. There's nothing about this packet that's the truth. So hopefully there's a couple of, I'll be a little bit more truthful today than the coffee in there. So anyway, so I'm going to talk about code review. And we're going to give you a product demo and do all that kind of sales-ish stuff, I suppose. But I want to talk about code review, developers reviewing each other's work, and about the things in code review which are true, whether you use our tool or another tool, God forbid, or no tool, and just best practices that we've found over a decade of doing code reviews, huge studies. You'll see all this kind of stuff as we go. Hopefully things that you can take away and use. Even if you just want to use a small piece of it in a small part of your process, hopefully you'll get some useful stuff here. So my name is Jason. I started SmartBear software about 10 years ago. And we have this tool called Code Collaborator, which is a peer code review tool that integrates completely with RTC, which again you're going to see in a demo at the end. So first, just in case, obviously everyone here is somewhat interested in code review, or you wouldn't have gone these extreme measures to be here. But still, I always think it's funny that most people don't do code review or don't do it very much. And I think it's funny because in the other areas of software development, other phases of software development, we always collaborate on the code, right? In all these other areas, it is a collaborative process. And yet, somehow when we get to actually writing the code, now it's time to go to our cubicles by ourselves and work in the, without help. It's kind of weird. Also, if you look at your own bugs, in fact, I encourage you to do this. Look at the last 100 defects that were found by customers or QA and ask, is it because of one of these other phases, or is it because of something that we did in coding? It's usually the coding. And so it's weird that in this phase suddenly we decide we don't need to help each other in that part. So I wrote this book about code review, which maybe some of you have. If you don't, you can go to codereviewbook.com and get one for free. But this is a book of all kinds of stuff, like the white paper that is associated with this session, all kinds of stuff that we've learned about code review. And by the way, so interesting thing about writing this book, of course, I had an editor, which is, of course, parallel to code review. And did you know that in America that there are more editors than writers? Which I think is an interesting commentary on what that industry thinks about how important review is. And it's obvious that it takes a human being to notice these things. And it's also obvious, especially looking at stuff like writing, that it's not about being smart. It's just human nature that when you're that close to things, it's hard to find the bugs. Duh. So we have code review. And really the question is, how do we not waste a bunch of time? So in some of the things I'm going to talk about, and definitely in that white paper, because I'm not going to do the whole white paper. You can read that for yourself and get all that data, right? So I want to talk about some stuff that's not just in the white paper, and something that I think is at least as important as all the metrics and data that's in that white paper, but people don't talk about a lot, which is that, like all processes, it's about people and not necessarily about not only about the data. And if the people aren't on board, if they're not having a good time, if they're not improving, then it kind of doesn't matter. So my favorite aspect of code review, I call the ego effect, and it's this. Let's suppose that you're a software developer and you're used to coding away by yourself in Cube, and one Monday the boss comes in and says, just so you know, this next feature you're working on, well, after you're done, we're going to put it on a projector like this, and we're all going to sit in a room like this, and we're going to critique it, just so you know. That's going to be on Friday. And he leaves. Sounds like a fraternity hazing, right? You're going to stand up there naked, and we're all going to like make fun of stuff. So you turn back to Eclipse, and you start working on a new function, and it puts that little comment thing you're supposed to fill out that you normally delete, and you think, well, I better fill that out or they're going to call me on that, so you start filling it in, and then you start writing the code and realize, well, you just said that this parameter can't be null, maybe I should actually check for that and assert or throw or do something. And in other words, knowing that other people are going to be looking at you and criticizing you or your work, hopefully that's not the same thing in your mind, just the fact that you know that's going to happen will make you automatically a more conscientious, better developer. Just stop being lazy on the stuff you know you're supposed to do. You don't want to be the guy that always forgets to check for null or something like that, right? Just doing it in any way, shape, or form, if you do code review, and you invoke the ego, everyone will immediately start writing better code. It's cool. So I also want to tell you a story about team building because, and I know when you think of team building, it's kind of like, oh my God, team building. It makes you think of like going to these retreats where you play stupid games and everybody hates each other at the end. But I want to talk about like a real story of team building, which happened at a certain company that everyone here is very familiar with, where there was a team in Austin, where we're based and I'm from, and there was a team of developers, and I'm not going to name the exact thing because, you know, I'm not allowed to. You know how the lawyers are, especially at that company. And so the team was given 30 offshore developers, 30 developers in India, with the instruction that they need to now write code faster, which really, we all know that that's not how that works. You don't just add people to a team, whether they're in India or not, and then magically the project goes faster. Once again, because of rules that someone who works at this very company invented, so they should kind of know better. So, okay. They started working with the Indians. Of course, it wasn't going well. So I went there, and I said, okay, but I get it. Like, we get the general problem. But what's specifically the problem here with the Indians? Why are you guys not getting along? And the lead developer, this is a quote, told me, the problem is that they suck. That was his in-depth analysis of exactly what was wrong with. So, okay, they suck. Why do they suck? And, you know, there's all this stuff starts coming out. Well, they didn't read we sent them a 70-page specification about how we write code and stuff. They ignore it. We've been on these conference calls at 7 p.m. Somebody's Wednesday, Thursday, whatever, and they're not listening. You know, that kind of stuff. So we said, okay. And we started with a code review process. And yes, it was with our tool, but the results would have been true no matter what, you know, what tool or what thing that they used, I think. But they started talking about code, right? They started discussing things inside code instead of these things. And so we came back in 5 weeks. That same guy, quote, well, those guys are pretty cool. And the reason he said that they're pretty cool, and another in-depth analysis, but at least it was positive, right? He's like, yeah, you know, it turns out that, of course, the Indians weren't dumb. They were green, right? They were inexperienced. And once they started just talking to them inside the code, they started learning very quickly and became productive in a matter of a month. And the reason is pretty clear, because people don't read or don't learn, I should say, and digest information through things like specifications and meetings, right? I believe, anyway, that software development is more like an apprenticeship sort of thing. You learn by being, you know, by writing code with other people, pair programming being perhaps the most extreme version, and that's fine too, but so is other sort of less time-intensive things that still involve people talking about code in the code. So another story I want to tell, see, this is not data, but to me, it tells us what we should be doing here with this whole process. So this is like a screenshot of our tool, and when we first got our tool going, of course, we have to write. We have to use our tool against every line of code we write, right? We have to eat our own dog food, or else one of you would ask us that, and then it would be embarrassing. So we do. So we first got the tool going, and we were starting to dog food it. And I was the reviewer. I was a reviewer of this code, and I saw this line. And I thought it looked a little funny to call a function on a constant. But this is actually a neat way to write it. You could write s on the left and integrate on the right, right? You could. But this way's better because why? Right, because if s is null, this returns false instead of throwing an exception, right? This is one of these little tricks that as you become an experienced Java developer, you just know this trick and you just automatically do this because it removes a certain class of bug. Nothing that's, well, I shouldn't say nothing that won't crash the spacecraft because, I don't know, sometimes when those things freeze up, it is stuff like this. But, to me, this is the kind of thing that makes a good developer. Like a million of these things. That's part of what it means to become a better developer. And I should have known better, too, because I have a background in C. And in C, we know to put the constant on the left in an expression like this because, right, because if I forget an equal sign, it will still fail because I can't assign 0, right? And so, yay, right? This is it. This is kind of, unfortunately, there's a lot of architecture and cool stuff, but unfortunately or fortunately, this is a lot of what we do. And the interesting thing about this story is, you think of code review as like the reviewer tells the author what to do and how stupid he is and all this stuff I've got to do, right? I was the reviewer, and I was the one who learned something because we're just talking about code. So very quickly when you put in a code review process, you'll notice that these kinds of things just like fly around the office because it's natural because you're looking at code. And it's fun to talk about this stuff and get better at it. And the last sort of point I want to make about this sort of social stuff is, does everybody know what a bus number is? Have you heard that before? It's the number of people who have to get hit by a bus before no one understands this file, right? And everything in the code has a bus number, and often the bus number is unfortunately like 1, right? Which is bad. Again, another advocates of stuff like pair programming, sorry. This is one of the arguments they use for pair programming is your bus number is never only 1. At least one other person has seen all the code. And if we rotate pairs, a lot of people have seen all the code. And that's, not just if someone gets hit by a bus, but just for scheduling purposes, it's bad if a bunch of changes happen in some part of the code that need to happen now and only one person can do it. Even just for scheduling, much less actually getting hit by a bus or leaving, it affects you all the time. So again, almost no matter what way you do code review, you can increase your bus number on as much of the code as you want. So that's sort of some of the fuzzy stuff, and now let's get into some data, because data's better, I guess, than fuzzy stuff. Let's see how we're doing there. Oh, good. We've got lots of time. So I guess because I'm talking too fast. So I want to show you some data here. We did this study at Cisco, 2,500 reviews. Maybe most interestingly, it was in an ongoing project, not at lab, not at a university, a real project for 10 months, people on 3 continents. This is in the video conferencing software that they make. And so lots of developers. So in other words, real data. And you'll see some of this in the white paper. Again, if you get that free book, not only there's lots of conclusions in there. Some of the data was not statistically significant, which in itself was interesting. Stuff we thought was important, we didn't find any kind of interesting correlation. It also describes how we threw out certain data points, stuff like that. So if you're interested in all that, we can do Q it. We'll have some question and answer too. But also all those details are in the book if you want to dig in and argue with stuff. Yeah, so it's all in the book if you want to see that. You can tell how it's weird. Like I put these weird references in. Like I once did a presentation with Orko from He-Man. Does anybody remember little Orko? It's weird. Different conferences, like everyone laughs at Orko, and then I'll go to some other conference and no one knows what that is. Just this weird little ghost guy. Anyway, so hopefully you've seen Beetlejuice. Otherwise, that's very strange. So, okay, first cool piece of data. This is a chart of over time. If you can't read it, this is minutes. Over time, how many defects do I find while I'm doing a code review? So for a single person, it might be, tick-tock, tick-tack. Oh, I found one. I found another one, whatever. And this is, of course, an average over a lot of people at generally the rate in which defects were found during the span of the code review. And what's neat is that there's this nice linear thing going till about an hour in. About every 10 minutes, they found a bug. And if you think about it, this is really efficient. 10 minutes of time, I find a bug. Not only do I find it, I know where it is in the code because I'm looking at code. And often I know how to fix it. Or somebody knows how to fix it because it's usually pretty clear. And again, it's often pretty simple to fix it too. Now, if you just think, even without like a ton of data, if you just think about processes in software development in which with 10 minutes of time, maybe you could call it 20 if you like double counted the author and the reviewer. Although in this case, actually, the reviewer was doing it by himself. The author was not taking time except to chat. But even if you bulked it up to 20 minutes to find and fix a defect, this is really, really efficient use of time for a while it's still taking just 10 or maybe you call it 20 minutes to find. Then it's useful, but then you see that there's this weird cusp. It's actually pretty fast, right? It's right around that 60, 70 minute mark that it curls off, and then suddenly it's not efficient for us to be looking at the code anymore. Now you can pick the theory you like about why this happens. You can say our concentration lasts about 45 to 60 minutes, like in about, I don't know, another 30 minutes you guys are going to have, butt's going to hurt, kind of ready to get up, stop listening to data and stuff, right? Like you kind of feel that that's about the time frame where focus starts to become less efficient. So maybe that's why. Who knows why? The fact is it happens, and so one of the sort of obvious lessons is not to do code reviews that take longer than about an hour, because we're probably, it's quite possibly wasting time. The next one, now this one's complicated, and not just because there's lots of dots, but it's useful to see why this is. It's instructive to see why this is useful. So on this axis, it's how fast we did the code review, how many lines per hour, 200 lines an hour, 400 lines an hour, so how fast I rip through the code. That's the easy part to understand. The defect density, this is the part that needs a little more explanation. So defect density is, for every 1,000 lines of code, how many bugs do I find on average? And that part's pretty easy to understand, right? Because of course with more code, in general, you should find more bugs, so that makes sense. But the part that's tricky is the fact that they're all over the map like this, and that's normal. It's normal for it to be all over the map because, think about if I'm doing a code review of an interface file, right, which almost literally has no code. It's all comments and sort of definition of some kind of API, right? And so I'm doing a code review of it, and maybe I find typos, maybe maybe I sort of argue with a little bit with the API. But it wouldn't be unusual to see 300 lines of interface file, which is almost completely white space and comments, and find very little and have a low defect density. Now, on the other hand, it's also very unreasonable, even rational, to be looking at a code that's deep inside some kind of concurrent access thing, and only 2 lines of code were changed, and there was a subtle bug about a race condition somewhere, and then there was another bug where it's like, look, this is totally confusing. You need to add a comment that really explains what's going on. In other words, you could change 2 lines of code and have 2 or 3 defects, easy, if the code is really complex and hard, right? And that would have an insanely high defect density, defects per 1,000 lines of code. It would be like crazy, right? In other words, it's normal for different code reviews to have really different defect densities in them. And that's what you see here. That's okay. So, and by the way, this opinion of mine, it differs quite a bit from the literature. If you read a lot of literature about code reviews or just defect analysis in general, they like to talk about the defect density. I don't believe that the average defect density is actually that useful of an average. It's one of these averages, like if you have a 2-hump distribution and you take the average, and the average is really not describing something useful about the data. To me, that's defect density. An average defect density is often not a useful thing anyway. So the thing to note here is this. This is normal. I want to see a spread of defect densities good. But as we go faster and faster through the code review, I stop getting high defect densities and I only get really low ones. That's a bad sign. And it kind of makes sense, of course. Like if I rifle through the code, I'm obviously not going to find all the defects that I would if I took my time, like duh, right? So that's duh, but what's not duh is the exact time that we see this thing. And it's not exact, right, because there's some dots. So like you have to use your own judgment of where you kind of see the line drawn. But I think it's fair to say that conservatively at 200 lines of code per hour, certainly by around 500 lines of code per hour, again, you review code that quickly, and the effectiveness of the review is going to diminish. So it's cool to, I guess, put an actual number on. And it's also cool to put a number on because of this. If you take the results, the last two results, and put them together, you learn something. If I shouldn't review code for more than an hour, and I shouldn't go faster than, let's just say, 200 lines of code an hour, then I shouldn't try to review more than 200 lines of code at a time. And that's actually super useful, right? Big code review is bad, and in fact we can put an actual number on what big means. 200, 300, maybe 400 lines of code tops, or else we are in fact being inefficient, wasting our time. That's the implication. Then we measured it to see whether like we could triangulate the things that we were guessing. And in fact, it was true. This is exactly that. How much code under review? Again, that defect density, which we hope is spread out. And if it's not, that means we're not finding all the defects that we should. And in fact, in this region, there were 0 data points. 0. So in other words, the data, that conclusion was, was supported by actual data that we saw in the study too. So another thing we found was this. Now this part is not a proper experiment. It's a big star. Because this was not something we even expected to study. This was something we discovered in the data. And so we tried to analyze it and draw some conclusions. But big asterisk, it's not in any way a controlled study. But I found it very interesting, and I think it's significant. But there you go. So what we found was this. In our tool, if the code author wishes to, the code author can go through and annotate the code first. Here's why I did this. I called this method. I put this over here because of whatever, right? Like explaining or prepping the reviewer. So we call this author preparation. And it's not required. This is the problem. So some people decided to do it. Self-selection, again, not an experiment. Okay. Some people decided to do it, and some people didn't. And there was a huge discrepancy in the average defect density. See, I just told you I don't believe in that number, but that's okay. The average defect density with preparation was half of those without preparation. And that's a huge, and it was statistically significant, but it was a huge difference. So we tried to ask why that is. Again, not an experiment, so this is subjective now. And so what we did is we picked 350 random reviews in which there was author prep. And we looked at it to try to see if we could subjectively decide what was going on. And there was at least 2 theories. I mean, there's more, but we had at least 2 theories. The optimistic theory was that the reason there were fewer defects found is just like when you teach someone something and then you really internalize it at that point. By having to describe what you did to someone else, you find a lot of your own mistakes. And you've experienced this sometimes, right? And as you're writing, I put this here, and wait, I shouldn't have, right? back, hold on, right? So that's the optimistic view, is you find your own errors in having to regurgitate what you just did. The pessimistic view is that the reviewers were primed, that's the psychological word, primed, to not find defects because the author says, I called this method. And the reviewer goes, yes, you did. Of course, that's not a code review, right? So, wait, should you have, right? That is actually the question. Or the author has all these explanations, and the reviewer's like, oh, wow, sounds like he knows what he's talking about. Cool, right? In other words, you're sort of not in the mode to find defects because you either now trust the author somewhat or you're in matching mode instead of thinking mode. And that's why we didn't find defects, because we're not trying as hard. That's the pessimistic view, right? Of course, there's probably the most likely theory, too, which is that since this was self-selection, the developers who were naturally more conscientious and therefore probably didn't have as many defects or found them were the ones who did it. And again, since it wasn't a controlled experiment, we can't know. But I submit to you that we looked at 350 reviews, and we tried to see which of these theories seemed correct. And by far, the optimistic view looked correct. And we saw evidence of this, like we saw people say blah, 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 and then next they would say, wait a minute, that's wrong. Then we'd see them uploading a new version, and they'd say, okay, now like we saw that. The other thing we saw was someone would do a matchy-matchy kind of comment or an explanation, and all of the time people were challenging it or arguing with it, or commenting on a line of code that wasn't already commented on by the author, showing that they were in fact reading other stuff and not just responding to the author. So in our subjective opinion, we think that author preparation is really good, which again is good news for efficiency because you can do this by yourself, right? Like whatever the tools are, you're not even involving other people yet in time. So in the sense of like time versus benefit, it seems like a really good practice. So all this stuff is awesome. Code review is the best. But the biggest problem is pretty obvious. It takes time. And it takes developer time, which is like one of the most expensive things we can do. So it's clear that sometimes it's efficient. That's kind of vague. I mean, it's okay, but it's kind of vague. So so what can we do to make sure that we're not spending too much time in this process and yet, of course, getting the obvious benefits that it has? So this is where different parts of the process might be automated, or indeed, you could use a tool like ours. Because this is normally what, the stuff that has to happen in a code review. You start with a developer, a hapless developer. I don't think hapful is a word. I don't think you can be full of hap. But anyway, this developer has no hap. Hapless developer writes code and wants to check it in, or does check it in to RTC, which generates a diff. And so we have to go find some reviewers, package up the code that was just changed in some way, in some file or something or other, send them to the reviewers who talk about it with each other and with the author and generate bugs, which they have to report back to the author in some way who has to fix it, package it back, give it back to them. And then eventually, hopefully, these reviewers check it off and they're fine with it, and then it finally can go back into sort of some kind of safe branch inside version control. And also, if we're going to measure whether we're being time effective, then I suppose you have to be measuring lines of code and how much time we're spending in it. And maybe you have to make reports and make audit trails and that sort of thing. And this is the reason why we made a tool for code review, because all of these steps are manual and annoying. And so as you watch the demo, the things to look out for is that all of these steps are things where, a computer is not going to find bugs automatically. That's crap. But it can integrate with RTC to know what kinds of changes need to be reviewed. It can package up those changes and send them to somebody else who can see them in some sort of form, and it can facilitate the communication, whether that's real time or not real time, depending on when everyone's at the keyboard. And it can keep track of the defects and whether we fix those defects in subsequent reviews. And it can keep track of all these metrics automatically, because you want to know how much time you're spending in this process so you don't waste it. On the other hand, sitting there with a stopwatch is not only annoying, but it doesn't work. In fact, when we were developing the, let me see, can I tell you this story? Do we have time to tell you the story? Yeah, this is a good story. So we were developing the algorithm for deciding how much time you spent in the review. And this is hard, because our tool is a web app. And so it's hard to know if you're there and doing something. And, right, that's just difficult. So what we did is we had a customer who was willing to sit there with stopwatches and actually time what they were doing with the tool. And we tried to, then we looked at our own logs, and then we tried to decide, is there a heuristic we could use that accurately enough reflected the real time that somebody spent in the review? And we did, and it was something along the lines of, if the activity like clicks and moving the mouse were close enough together, we assume you were doing it the whole time. If there was enough of a gap, then we assume you weren't. And of course, there's some parameters there that you tweak for reality, right? Stuff like that. And so that's pretty cool that we think between 20 and 30% of real time, which is pretty good. In fact, the fun thing we discovered is that being about 20 to 30%, with 20 or 30% error, how much time you spent, was more accurate than the stopwatches. Because people would constantly forget to start or stop them, or they'd go do something else. Like, the stopwatches were wildly inaccurate. So of course, you don't look at any tools, and not ours certainly, and look at a code review and say it took 12 minutes and 47 seconds. That's right. Well, no, it's not right. It's in the ballpark of right. And relative to the other ones, and in aggregate, it's giving you a good idea of like the order of magnitude of how much time you're spending, right? Like that's the right way interpret that. But it was fun to see that it was like way better than the stopwatches. And by the way, another fun story about that. I was at another company once who required stopwatches, and they had some rules. Like, if you go check your email, do you pause the stopwatch or not? Or what about a chat? Or do you have to turn off chat? Like, they had all these rules. And I'm not kidding. One of the rules on the chart was about if you go to the bathroom and whether that requires the stoppage of time. And so the rule was, if it's number 1, let it run. But if you're going to go number 2, and we don't know how long you're going to be in there with your, IBM Rational Magazine Today issue, then you got to stop it. So hopefully we've eliminated certain undesirable processes. So we're going to do the demo last. So I'm going to skip right through there. So hopefully, and we'll do the demo in just a minute. Hopefully, what I've done is a little bit of inception in a sense, in that you feel like, okay, got to do something in code review, something, maybe not review all the code like we do, although a lot of our customers do. Because once it's efficient, there you go. But if you're now thinking like, okay, we got to do something with some of our code, but I don't want to do too much because it might be a waste of time, and I want to measure whether it's a waste of time or not before rolling it out everywhere and so on, where can I start? What can I do a little bit of that probably has a good return on time? And, maybe you'll never do more than that. Maybe you just stick with a small sliver that definitely has a good return on your time. Or maybe you sort of let that grow and keep measuring whether it's a good return on time and just stop when it's not. So I wanted to give you some very simple ways to get started like that you can do tomorrow if you want. Wait, yeah, tomorrow's Friday, maybe Monday. So one of the obvious things is just pick certain files, like you have a stable code branch that you sometimes make patches on. Well, if you do patches on a stable branch, like it's really clear that it's worth spending extra time to make those right, because a bad patch like that obviously costs a whole lot of money and annoyance and so forth. So, maybe just those. And especially in RTC, when you have the ability to have all kinds of code paths and branches and streams and whatnot, then it's sort of natural that you would do something like that. Or another one is, I have a core module that 97% of the code indirectly runs through. So obviously changes to that. Super important for that to not break. Super important for the unit tests on that to be really good and so forth. And so maybe that's worth putting extra time on in a code review sense. There's also, in every project, that there's like at least 1, maybe 5 files that nobody ever wants to touch. This is the scary, complicated, horrible file, right? Everyone's like, oh, yeah, I know. So a really simple process would just be, if anybody touches one of those, code review time, because no one's going to stand up and go, I'm super comfortable messing with this 4,000 line crazy class, right? No one's comfortable, so get help. Like, it's kind of obvious, right? This was a fun one that one of our customers, well, maybe more than one, does. It's a little extreme, but it's kind of fun. Their philosophy is, we're going to code review the unit tests and never code review the code. And the theory is that if the unit tests are complete enough, but not over-specified so that it's hard to make reasonable refactorings, reasonable changes, then, and here comes the rock and roll quotes, it doesn't matter what the code looks like, because it's automatically maintainable because unit tests are good. If the code's too slow, but we can fix that really with great confidence. If the code doesn't have enough commentary, well, but it works, so we're willing to take that. Now, personally, I think it's a little extreme to never look at the code, because human beings are, in fact, going to have to look at the code, and there's no time like now to fix either obvious things or just make sure it's understandable by another human being. But it certainly does save you some time, and it definitely gets you like some very tangible value, both in terms of correctness today and maintainability tomorrow, to just look at the unit tests. And plus, unit test code reviews are fun, because they're like a little treasure hunt. Like, okay, you need to add these tests, or whatever, right? Like, or you can argue about whether some weird corner case ought to be this way or that way. So it's also kind of fun. But I feel like code review that's both the unit tests and the code is, of course, more effective and pretty fast still, because when you look at code and unit tests, you will naturally do the unit tests first, because if they're wrong, right? If it's clearly a bug, then, yeah, who cares what the code looks like, right? Clearly, first, it has to be correct. But then what's fun about that is, if you've decided the unit tests are right, then when you do look at the code, you're not looking for correctness, which is great, because that's annoying and it's hard, and you're not that good at looking at correctness in code, right? Like following if statements and repeat. Like you're not going to find a lot of subtle errors looking at the code without spending a ton of time. That's what the unit tests are good for, right? All those kind of corner cases. So it's actually pretty neat. It's pretty efficient to use unit tests to look at correctness. And then in the code, you're looking for those bigger concepts like scalability or error handling or whether it's just possible to read, possible to understand what's going on. There's enough sort of commentary, just enough commentary, right, to understand that which is hidden, that which is not encoded in the code itself. So I feel like it's still pretty efficient and valuable to look at both. But anyway, it's one way to save time. Then, of course, you could decide to do code reviews based on the phase that the project's in. Maybe at the beginning when you're doing lots of new code and the code base is churning a lot, maybe you decide code review's not as valuable because a lot of this code's going to be different in a week anyway. Okay. But maybe when you get to that stage where you're in feature freeze and like everyone's really careful about like introducing any new bugs at this point. It's not, any new bugs is kind of like the big thing. And QA is trying to get a good handle on where we are exactly, and you sort of get into that place where everyone's kind of doing this. Like, that's a good time maybe to take out code review and say, this is important to us now. Let's use code review to help us do that. And then actually, I think a great process is the same as my mom's answering machine message, which is that. And people like to use process, I guess, to sort of control what people do and enforce, I don't know, good practices on folks. But I think the bottom line is that if you don't trust your developers, if you can't trust your developers to make, in general, good choices, you're never going to have very good code. It's never going to be an efficient experience because they're not trying or they don't want to or they can't or whatever, right? So assuming that your developers in general want to do a good job and the process is just there to do natural mistakes, which again is what I think code review is, natural mistakes that of course you make, just like when you write. And therefore, you can also trust them to decide when code review is going to be effective. You know when you make a change and it's really just a typo in a string constant somewhere, I don't really need to waste someone else's time. And you also know when you make some change that you're not that comfortable with, where there's no unit test coverage, and you're not the domain expert in this part of the code, but you were helping out anyway, and you kind of get that feeling like, like I have no confidence that what I just did didn't break something. That's when you ask for a code review, maybe from someone who is a domain expert in this part of the code, hopefully that, so just to get the double check, and you should get a double check. So I feel like leaving it in the hands of your conscientious developers is not a bad process. And probably a good use of time. They won't, in general, waste too much time on that. They feel they need something. They feel they need a double check. Good. I'm glad you asked. Let's just have a process in place that's easy to measure that we're doing that. And then the final thing, and I guess this gets back to that at the end, it's just human beings doing stuff with each other. If your group does not want to do code review, and they want to demonstrate that code review is ineffective, they will be successful, right? Do a code review, they look at it, I don't know. And then guess what? They're going to spend a lot of time and not find anything. Code review is ineffective. Okay, you proved it. So clearly, if people are not on board, it's not going to be effective. You're right. They got to want to do it. So that's where the sort of general, any kind of code review you do part can conclude. And I guess now we'll do a demo of the tool specifically with RTC and then take questions. Actually, let's do that. Make sure we have time for that.
Yeah, so my name's Justin Collier. I'm one of the SEs here at SmartBear. And I'm going to walk through the product and just kind of show you what the workflow looks like and kind of give you a good overview and feeling for how a review works. And so we'll run through this pretty quick because we don't have a lot of time. I want to make sure that we have an opportunity to answer questions. And if you do have questions that are more technical about, hey, how does the product work, and you want to see a demo at some other time, we'd be happy to set that up for you. So what I have right here is of course, RTC pulled up. I've got my task that I've created. I've pre-created this. I've got some code in here as well. It's already set up. And the way that we work is we set up an integration that's going to trigger off of a state change. And so when I come in here and I've completed my task, what actually happens is a review is automatically started. And so we're going to go ahead and do that here. When we click Save, this review is going to go ahead and get started. And you'll notice if I come over here to links, I'm going to do a quick refresh. And now I've got Code Collaborator Review, review number 76. And I can double click on that. I'm going to open up that perspective. And here within InRTC, I'm ready to begin and create this review and get it sent off to some reviewer. But you'll notice I don't have a reviewer defined. Now, had I had an approver within InRTC, it would have automatically been included here. But since I don't, I have the ability to drag and drop who I want to have participate in this review. And I'm going to add them as a reviewer here. Now, I also can have observers. And these are maybe a junior level person who's going to take a look at the code. And you don't really want them impacting the flow of the review, but you want them to learn from it. And so at this point, we're actually ready to begin the review. So I'm actually going to save my changes here. I'm going to scroll down. And you can see we've got our files attached. And we're going to begin the review. Now, what's happening at this point is Justin Collier is going to be notified that he needs to perform a review. Now, he can do that if he's already in InRTC. He may get a notification through an action item. He can also receive emails, RSS feed, and what we've pulled up here is the web UI aspect of the service as well. So if he's not in InRTC, maybe he's on the road, whatever, he can actually pull it up here and take a look. So at this point, he's going to go in and begin the review process. And you can see all kinds of general information. We're going to skip a lot of this because we just want to get kind of the heart. And here's the review material. So he's going to come in. He's going to take a look at this file. And when he comes in, he's going to begin the review, and he can start to make comments. He can just make a general comment about the file. Or he can go in and specify a comment at a line. And so for now, he may look at this and say, gee, that's a lot of, white space. What's going on there, right? So just a comment against the line there. Now you'll notice if I scroll down, I'm going to take a look at this, and he might come in here now and say, well, wait a minute, this is a defect. This really needs to be reworked. Now a defect is different than a bug, right? A bug you may have already released into the product, and so now you need to actually track that as a bug. Whereas a defect for us is more about, hey, this is something within the code that we're reviewing that you need to go address before we move any further along. And so at this point, he may come in and just make a comment about this from a defect standpoint. He says, I would change this and use k plus equals 2 or whatever, right? And he can also come in here and select a severity, and he can select a type. And you can see this is just a drop-down list. I'll just pick one at random here and submit that as a defect. Now those are custom fields. You can manipulate those and change those. And now I've reviewed this particular file, and I'm finished with this. And I'm going to go ahead and click Done. Now, if I was good, I'd go look at the rest of the files, but we're just going to skip right through here, and we're going to say, hey, we're finished. We're done doing the review. Let's get this back over to the author so he can go fix the code. But I'm actually going to choose File Activity Occurs here when in this Moving On section. And what that's going to allow me to do is basically prevent any notifications from other reviewers that might be attached to this. So I'm going to choose File Activity Occurs because I want him to rework it before I get notified again. I'm going to click Finish, and now we're ready to move on. I'm going to go back to doing what it is I'm doing. Now within InRTC, it's automatically updating all of this for you. And you can see we just got another update. And as the author, if I open this file up, I can go in and take a look at the comments. And you'll notice everything's in yellow. These are items that I haven't read. Now, had I been in at the same time as Justin, those comments are going to be coming back and forth. And we're going to be able to communicate quickly about a particular file. But if I'm not in the file at the same time, it's not a big deal. We're going to thread all of this stuff out, kind of like a news group, and you can come back and take a look at it, read your comments, and then move on. So from here, we're going to look at this, and we're going to say, hey, yeah, okay, I understand. I probably need to fix that. And if I click on this section, it'll actually drop me straight down to where that defect is listed. Or if I'm clicking on the comment, it'll bounce me back to that. And I'm going to go ahead and read this and say, okay, great. Mark that as read. Now I need to go in and fix the items that were mentioned. So we'll delete all this white space out of here. And we'll come down here and we'll change this file, this area down here. We'll make a change. and I may add some other files, make some changes, whatever. And now I'm ready to actually save this off, and I'm going to commit it. So I've reworked my file. Now, what I forgot to do just a moment ago with this task was actually change this task back to a reopen task. And so we're going to do that now. And since we've reopened it, we've reworked our file, we're going to come in and we're actually going to mark this complete. And now this process is going to continue. We're going to open this back up. And here's my files. I've made my changes. And I'm going to say, hey, my defects have been fixed. Proceed to verification. What we're essentially doing now is we're telling Justin, hey, I fixed the file. Now go look at it again. And so that's when that notification is going to kick off. And so he's going to receive that notification. Maybe it's an email, again, RSS feed. He's going to open this up. He's going to come in. He can see, oh, okay, there was one of the files that haven't been changed, but this one was reworked. So we're going to open that up. And now I can see a comparison. What did we have originally and what do we have now? Well, here in red, pink color here, we can see that these have been deleted. Down here, as we scroll down, we can see that this line has been changed, and it's highlighted in yellow. So we make it very easy to track what's been going on within the code when a change is made. Now, the other thing that you'll notice is what was made against line 13 in here, we've got listed out as 6. So we can see the changes. We've deleted some lines. We thread that out. We keep track of what's going on against the lines. So it makes it very easy. Now, he's going to be able to come down here, and he's going to say, okay, yeah, he made the change exactly the way that I wanted. So I might mark this this defect fixed. But I can also track this externally if I want to move it outside of this particular code review. But again, we can always get more in depth at another time. So I'm going to mark this fixed. That's part of the role of the reviewer here. And now this file looks great. I'm going to click Done. And I'm saying, hey, I'm finished with this review. Now, at this point, this gets updated, and you can see that the review has been completed down here. And so, again, this is automatically happening. And the only thing left to do is to check this in. We don't have to we can just deliver this at this point. We don't have to do anything else for this particular code review. And so we're complete. And so it's a very easy process to go through and run a code review from within RTC. I can stay within the tool. I don't have to leave it. And I can go off, start the review, and then go off and continue to work on another project. So we make this very easy for you. We just want to make sure that we illustrate exactly how RTC works and our integration there. We've got a lot of great features, and as you guys know, we're ready for Rational with RTC Clear Case as well as Center Case. So at this time, what we would like to do is take a few minutes to answer questions you guys might have, maybe from Jason's presentation or anything about the product itself. And again, at a later time, we'd be happy to set up a demo for you, personalize it to you. Jason, do you want to kind of field questions?
Sure. All right, thanks. Is this on? This tool looks really great. I have a couple questions. Other workflows, or if I've defined a custom workflow in RTC, can I define where this kicks in?
Yeah.
Yeah? Okay.
Yeah.
And what other, like you've got Java nicely, syntax highlighted, C, C++, Perl, Python, what do you guys do?
So inside the Eclipse, we use Eclipse and syntax highlighter.
Right.
In the web app, we have everything you mentioned plus more.
Okay. Perfect. Thanks.
This may be somewhat related, but with preconditions, does this tie into any of the preconditions where you can require CodeBear type of code review prior to a deliver, for example?
Yeah, I mean, there's no, it's not automatically defined, but you do have that capability. So you want to defer your
Yeah.
Sure. So, and that's where tracking it externally comes in. you do have that capability. We call it a defect because it's something you need to address now, but if you want to move it outside of this particular review, at that case, you would go ahead and file that as a bug in your tracking tool.
I think that to expand on that, that's a step further with RTC.
Sure.
Track externally. So how does that relate to a work item in a team concert?
Will, can you explain that?
So there's not a direct integration there where you can track externally and automatically populate feedback. But essentially what you do is you go in and create yourself feedback and grab a link to that and paste it in and track what externally acts.
The other question is about, as I run peer reviews in my organization, do I have the ability to come back and do during my retrospectives, reflections, year quarter, and basically say, help me understand the effectiveness of my reviews?
Yeah, absolutely. We have a series of reports that are just kind of predefined in CAN that are available to you. We also have the SQL available as well, so if you want to go create your own custom reports, that's something that you can do.
Is there something you can just pop up and kind of show us?
Absolutely.
The reporting capabilities of this?
Yeah, absolutely. So from a report standpoint, I'm in the web UI here, and we can see we've got a series of different kind of custom CAN reports. I can go look at recently completed reviews. We'll go look at that. All of the different columns that are available to me here. If I want to set up any filters, I'm looking to find out, hey, coming from a specific author or whatever, and then I can run that report. And it'll spit out all the different reviews for me. And then I can actually drill down into these different IDs. As I mentioned, we've got the SQL here, so you can just click on that. It'll dump it out. You can go create your own custom reports if that's something you want to pursue as well. Does that help? Okay, great.
Yeah, that's actually a relatively unique little feature, that SQL thing, right? The idea is you use this to build basic information, and maybe it's sufficient and you drill in. But if you want to, maybe create a view out of it so that you can run your own reports, the fact that, we've defined our schema, but, you read a schema definition, I still have to figure out exactly what the joins are and everything and exactly how to get the data I want. So the fact that, you can export this as a CSV and other things like that, which is also useful, but you can actually see, this is the query behind exactly this. You can just take it, paste it, maybe make a view or a subquery out of it, and continue from there and not have to understand our schema. Pretty convenient.
If I have a large program, how do you focus the review on just on the changes that have been made to it? So if I've got a 5,000 line program, I don't want to spend time reviewing it.
Yeah, so that's what it does by default. So those diffs that it showed. So supposing that file was in fact that long, it would say okay, I'm skipping 2,000 lines here, and then show you that diff with some context. And you can even ask for more context right on the screen. So in other words, you're already looking at the differences and not the file, unless it's a new file.
So does it know when the last review was done on that code screen?
It doesn't look at the last review of the code. It looks at the changes in question, right? I've decided that this is a change set. And now it's going to look at that change set, regardless of whether there were or were not reviews before or after it.
So what if I make it, I guess it's pretty simple, or if I do two change sets, say these files are the hard ones that I want reviewed, and these are all the other files that basically I was just updating the API call set. So there's no point in reviewing those. If I put them in two change sets, does the tool automatically, or I have to tell guys, only look at these ones?
There's a couple answers to that question, because there's lots of different ways that a review, that you may want to have different parts of the review. So one answer is it all goes in one review, but you use comments to annotate not these, or an overall review comment just to say just ignore all the files under this. It could be that you put one change set in review and one not. That also depends on whether the company workflow allows you to do such a thing, gives you that flexibility or not. So I guess it depends. There's lots of ways of sort of saying that or having different reviews or not reviewing some stuff. Okay, well, that's our time. We're going to hang out up here or just outside anyway, so if there are more questions, just come up and talk to us. Thanks for your time.
Appreciate it.